Let's learn in this Lightboard session how we can use external DNS in a Kubernetes cluster to create and update custom domain names within the DNS service. The main objective of an external DNS is to create and update the DNS records for the public services that we create in the cluster and also for the ingress resources. Let's start first with the problem that external DNS solves. So within a Kubernetes cluster, I would have one or multiple pods for my applications. So those could be one or multiple ones. And in order to expose this application inside this pod, I have two options. Either I can use a Kubernetes service. So I'll go to create a service. And that service actually would go to route traffic to those different pods, and that service could use a public IP address. So from here, if I'm using Azure AKS, for example, that will go to provision a load balancer, and it will go to provision a new public IP address for that service. So from here, that will be exposed through public IP. Exposed through a public IP, of course, here I'm supposing that this service that I have created is using the type load balancer. So then it would have a public IP that will serve, let's say here, 20.30.40.50, just as an example. But this is not the recommended way to expose public services on the internet or on an AKS or in a Kubernetes cluster. However, what we should be using is another service and an ingress resource. So how we expose that ingress resource, so typically we would go to create another service actually. But this service will not have the type load balancer. Instead, the type of this service is going to be cluster IP. I don't need to expose it directly. So it could be cluster IP, and then this service actually, it's on this way, it will go to be used by an ingress resource. So here I would have an ingress, something like Nginx ingress controller, that will go to route traffic to that service and then to my pods. And that ingress will be exposed on a public IP address. So somewhere here I would have a public IP. And that is actually the same public IP created for the ingress controller. Okay, it will be attached to the load balancer, and that would have its own public IP. Let's say this is public IP 30.40.50.60 as an example. Okay, so now for my users who will use their web browser, for example, in order to access the application, they will so they can use actually I can give them this public IP address, and then they can use it to browse to access the application. But that's not a good user experience. So it would be better if you can use custom domain names, and we map those custom domain names to these public IP addresses. And actually, that's the configuration that we can apply on a DNS server, like for example in Azure DNS. So in Azure DNS, I can have my custom domain name. Let's say that's mycompany.com, for example. And then what I want to do for those two applications is that I want to give each one its own custom domain name. So for this public IP, for example, I want to give it a dedicated custom domain name. Let's say that's going to be app1.mycompany.com. So that's the custom domain name that will take me to this public IP 20.30.40.50. And then I can have a second one or a second custom domain name. Let's call it app2, for example, .mycompany.com. And that second one will go to take me to this public IP address, which is 30.40.50.60. So then my users will be using those custom domain names instead of this public IP. So I can do this configuration manually, and each time I create an ingress resource or a service of type load balancer, I will get that public IP, and then I will go to the Azure portal and insert it then. But then once that service changes its IP address because that service gets deleted, or this ingress changes that IP address because maybe I have changed the ingress controller and so on, then I need to go to synchronize that change into the DNS zone. And of course, that's not a recommended way, because in Kubernetes and in the cloud, we are always looking for automation. We are looking for ways how we can automate those type of operations. So how can we automate this step right here? Here, where we'll be using the external DNS. So external DNS will be installed inside the cluster itself as a pod. So it would live inside this part right here, where we would have that component for external DNS. External DNS, once it's installed inside my cluster, it will go to connect to the API server in order to scan the configuration of the services and also for the ingress controllers. So it should be able to access those services actually, and also to access the ingress controllers. So it will detect that the configuration for the ingress controller. And by the way, within the ingress controller, when we want to use this IP address, for example, we will use the host. Inside the YAML of the ingress, we will be using something like host up2.mycompany.com. Okay, so it will read that configuration, and then it will go to try to synchronize or apply this configuration into the Azure DNS. So it needs to authenticate and connect to that Azure DNS. How this authentication will be done? So here we have mainly two options for today. First option is to use for authentication is actually to use either a service principal or a managed identity, an Azure managed identity. For the managed identity today, it's supporting only the kubelet managed identity, which is not ideal because that kubelet is available to all the pods within my cluster, and it's lots of rights actually to give it access. It's lots of risk to give it access to that Azure DNS, because any other process in my cluster can go to access that managed identity, and with it, it will be able to get a token that will give it access to the Azure DNS. So however, you can use this option, but if we just disable access to the EMDS instance, I have a video that explains how you can secure access to that managed identity using a network policy that will disable access to the EMDS instance metadata endpoint. And then the second option that we can use is service principal. By the way, with managed identity also there are a workaround today available, which is using pod identity. Pod identity will intercept access to that EMDS, and it will block all pods except the pods that are allowed. However, pod identity is today, actually it will be deprecated somewhere soon, and it will be replaced by workload identity. And workload identity is not yet supported in external DNS. So for the authentication, mainly we will be relying on the service principal for today, okay, until we get the managed identity supported for a user managed identity. So for that SPN, we'll go actually to create a file called azure.json. So remember, this is specific to Azure DNS. If I'm using another DNS server, and external DNS supports lots of others actually from other cloud providers, each one would have its own way for authenticating. For Azure DNS is that Azure JSON file. This one will it's JSON file that will contain the app ID for this service principal, and then it will contain also the secret for the service principal, the resource group, the subscription ID, and the tenant ID. And because I want the service principal to be able to access that DNS zone, then I will give it the right airbag role in order to have that access. And those airbag roles are actually a reader on the resource group and a DNS zone contributor. Once I've created that JSON file, then I'll go to save it inside a Kubernetes secret, okay? I'll save it into the secret, and then I'll be configuring my external DNS pod or deployment to read that Azure JSON file from a secret. So I'll mount a volume and mount that file into that volume, and then the external DNS pod will be able to read that Azure JSON, and then it will use it in order to get access to the Azure DNS. So from here, it will be able to access the Azure DNS, and it will be the component that will go to create those records for me. So it will create that one, and then it will create this one. And external DNS will be running on my cluster, and it will be always watching for any changes to the ingress or to the public services, and then it will reflect that change into the Azure DNS to either to create a new custom domain name or to remove them or to rename them and so on. I hope this was helpful. Thank you. Let's learn in this lab how external DNS really works. So in this GitHub repository, you will find all the scripts, all the YAML files that I'll be using in this lab. In this lab, mainly, we'll go to create a service of type load balancer and an ingress resource that will use a custom domain name, and then we'll go to install external DNS with a secret that uses a service principal, and then we'll configure it in order to configure, create, and synchronize the custom domain names within my Azure DNS zone. Let's get started. So from the command line here, I have already created an AKS cluster that have 3 nodes, and then I have installed the Helm chart for that will install an ingress controller, Nginx ingress controller as an example. So by the way, external DNS will support almost any ingress resource, okay, whether that is Nginx or whether that is application gateway ingress controller or any other ingress controller. After setting up my environment, I'll move next here to go to create a new private DNS zone or a new public DNS zone. So either I can use or I can create a new one, or I can also reuse an existing one. Actually, I have an existing one that is already mapped to a public domain name that is osam.cloud. That is my domain. Okay, so I'll go to use it. If you don't have one here, you can just create a new one, and that would be fine for this demo. However, you will not see that your application displayed in a public or into your browser. Okay, it will just create the A record, but it will not resolve it on the public internet. So that's fine. Here I have so created that DNS resource. Now if I switch to the Azure portal, I can also go to create that DNS zone within the Azure portal. If I go to create a new resource here, so specifying the resource group and then the name of the custom domain name you want to. After that's done, I would have here my DNS zone. Now I'll move next to configure the authentication for the external DNS. So before even installing the external DNS, I will go to create or to set up the authentication. So we said either it uses a service principal or a managed identity. In this demo, I'll be using a service principal. So I'll go to create a new service principal using the command izid create for airbag, give it a name. Then I'll go to extract the application ID and the password. So note that service principal actually have those different fields. So if I go here to display it, you will see it will display something like this, where you'd have the app ID, display name, password, and tenant. So I'll use this information in order to give it to the external DNS, so it will use it to authenticate to the Azure DNS. So the service principal for now, actually, it does not have any airbag resource. So we'll go to assign it some airbag resources that it needs in order to be able to connect and authorize into the Azure DNS zone. So for that, I'll go to fetch the DNS ID. Okay, so using here the query AZ group or AZ network DNS zone show then the ID of that DNS zone. Once I get that DNS zone, I'll go to fetch the DNS resource group ID, also the resource ID for the resource group, and then I'll give it 2 roles. First role is going to be the reader over the resource group where I have the Azure DNS zone. Okay, and the second role that it needs is actually the DNS zone contributor over the DNS zone ID. Okay, so the service principal have these 2 roles required, reader and zone contributor, DNS zone contributor. Now I'll go to check those roles were assigned successfully. So I see here the 2 roles are created successfully over my DNS zone. After that, I'll go to create the secret or pass the information about this service principal into a secret in Kubernetes, so that later external DNS will go to use that secret in order to authenticate to Azure DNS. So I'll go here to use this script right here that will go to provision to create an Azure.json file. Okay, that JSON file will contain the tenant, the subscription ID, resource group name for the DNS zone, and here I'm using environment variables to pass those values. And then it will use also the client ID and the client secret from my service principal that I have created earlier. If I show the content of Azure JSON, I will see this information displayed right here. Next, I'll go to create a new namespace where I want to install the external DNS and where I want also to put my secret to be used by external DNS. So here I'll go to use kubectl, create secret, give it a name, and then pass the Azure JSON as a secret file. Once that secret is created, I'll go to verify it. So by kubectl describe secret, and you'll see here my Azure JSON is available there. So external DNS it will be configured to read that Azure.json file. Let's see how that works. So here I will move to the step number 6, which is deploying the external DNS. But let's first take a look at the external DNS YAML file. So here I have that YAML file. Actually here it depends whether in your cluster you have airbag mode enabled or not, and here I have airbag enabled, so I want to install it with a service account and with a cluster role that will have the roles to get, watch, and list the services, the endpoints, pods, and nodes within the cluster. And it will have the same roles for the ingress. So it will be able to get, watch, and list all the resources or all the ingresses created in my AKS cluster. Remember, this external DNS will go to watch for these resources. And then I'll go to create a cluster role binding so that I'll give this service account this role, this cluster role. Okay. Then I'll go to create a deployment. Here, this deployment will go to deploy the external DNS pod into my cluster, or the Docker image into my cluster. And here I'll pass some arguments. So look at here, I have the source equal service and ingresses. I can put just one to say, for example, I want to just watch for the ingresses. I don't want to configure it for the services. So this means even if I create a public load balancer for my service, I don't want to map it into my DNS zone. Okay. And then the provider is Azure, because here I want to use Azure DNS. If you are using Azure other cloud providers like AWS, then this should be AWS. And then I'm mounting a volume, and that volume will be used in order to read that Azure.json secret file. Okay, so external DNS expects to find that JSON file under this path /etc/Kubernetes. Another important stuff here is the namespace used for the cluster role binding. Okay, so by default you will find it's default, but that should be changed actually to reflect the namespace where you install the external DNS. And by the way, this YAML file, I found it actually on the GitHub, on the official GitHub repository for the external DNS project on GitHub. Great, let's now go to deploy external DNS in our cluster. So I'll go just apply external DNS.yaml file into the namespace that I have created for it, which is external DNS. And yes, by the way, you might ask, can I install it through a Helm chart? And yes, you can do that. So external DNS itself provides a Helm chart, and there are other Helm charts provided either by Bitnami or by some other providers. Let's go now to verify the deployment of the YAML file for external DNS. So you see here a new pod was created, and now we have the service account for external DNS, and the secret is available already, that we already deployed it before. Now let's go to deploy a sample application in our AKS cluster. So here I go to start first with an application that will go to deploy a deployment object. Okay, it will deploy the sample ASP.NET app image. This could be anything actually, and then it will go to deploy a service, and the service will use this magical annotation that will be scanned by the external DNS. And note here it already starts with external DNS, and here I will put my custom domain name that I want to give to this service. This service uses a type load balancer. It means a public IP address will be created. So external DNS will read that public IP address and it will map it with this custom domain name. Let's see how this works. So I'll go to deploy first that YAML file, and that will go to deploy a pod and also deploy the service for me. And that service would have a public IP address. Let's wait just a second and it will be displayed. And yes, here we can see that public IP address that will be used for this public load balancer. So now external DNS should be doing some work. So let's get the pods for the external DNS. It's this one, and I want to read the logs to understand what it is doing right now. So I'll go to use kube control logs -n, or actually the name of the pod, and then -n, the name of the namespace, which is external DNS. And from this log, we can view, so first of all, the external DNS, when it starts, actually, it will look for a connection with the control plane or with the API server, actually, in order to be able to read the ingresses and the services resources, okay, to read their configuration and to detect if a new service or a new ingress was created or if they have been updated. So it needs to synchronize those config. And then it will go to create or update or delete the A records. So on my DNS zone, actually, I did have an A record with the name app1 from the previous demo that I have created. And it will go to delete it, and then it will go to update it again. So it will go to update it to use that public IP address for my service, which is here 253.191. That is the same public IP created by the load balancer. And here tells me, yes, it did update it successfully from my domain name from Azure DNS zone, which is here usam.cloud. So here, if I go back to the Azure portal, and then if I go to refresh the configuration for the DNS zone, I will see here app01 created with the public IP displayed from my portal. And you can see also the 2txt configurations that were added right here. So if I click here on app01, I will see here the custom domain name created for me. I can go to copy it, open a new window, and yes, here I would see my .NET application, my application exposed on a custom domain name. And I'll give you a bonus here. If you like using the Azure CLI more than the Azure portal, you can use this command line AZ network DNS record set a list in order to list the configuration for the Azure DNS. And you would see here the IP address for that record and also the FQDN or the new custom domain name that is used and associated with that public IP address. Great, we have seen how to use it with a public service, but typical use case for a custom domain name is to use it with an ingress resource. So in our cluster, we should deploy an ingress controller and then use the ingress resources in order to expose safely our services into the internet or even internally to our end users. So here in this example, I'll go to create a new deployment that will use the same Docker image, and I'll create a service. But note, this service does not have the annotation as before. It doesn't need that. And it's of type cluster IP instead of load balancer. Okay, so the service is still private. Next, I'll go to expose the service with an ingress resource. So I'll create an ingress resource on my cluster that will go to use the ingress class name Nginx because I have installed Nginx ingress controller in my cluster. I need to do that actually. And then I'll configure it to use this host name within the ingress resource. So I'll specify here app2.osm.cloud in order to expose this ingress. Let's go to deploy that app ingress resource. So that will go to deploy a second pod, and then it will deploy a second service, app2 service. It doesn't have an external IP, and then it will go to deploy an Nginx or an ingress resource that will use the host app02. Next here, we would have, so this configuration should trigger the DNS, the external DNS, in order to, so that it will go to scan and retrieve the configuration of this new ingress. So here, if I go to look for the logs from that external DNS, I should be patient here because external DNS will not be triggered immediately. It will wait for a few seconds actually. So let's try again right now, get the logs. And yes, now we can see that here it will go, it detected actually that a new ingress resource that was created, and it will go to connect to the Azure DNS, and it will go to update or synchronize the configuration there. So it will go to add a new custom domain name to my zone. It will call it app02. I can view now the configuration for the DNS zone in my Azure subscription using again the command az network list. And here I will see a new one added, which is app02usam.cloud, that will use the public IP address of the ingress resource or the ingress controller. And of course, now if I go to the Azure portal, refresh the DNS zone configuration, I would see a new record for app02 along with the txt files or the txt records for that app02. Now if I click on it, I will see the configuration, the new custom domain name, and the public IP that was chosen for there. Then if I move to my browser, I open that custom domain name, I will see here my application will be exposed on that custom domain. I hope this lab was helpful, and if you are looking for more content you can go to check out my YouTube channel where I post more videos about DevOps, Kubernetes, AKS, and Terraform. Thank you.